Hello, my name is Evan, and welcome to my tutorial. Today I will show you how to create a project in Unity containing real-world terrain. Here, I demonstrate how to work with a third-party Unity asset downloaded from the Unity Asset Store called World Composer. I have most sincerely appreciated using this wonderful asset myself, creating various scenes and projects using inspired landscapes I have visited before, such as right here in the Canyonlands National Park in Utah, and also at Mount Rainier National Park in Washington. I can come up with a number of examples to share why this process would be most useful. It can be applied to myriads of scenarios requiring geo-accuracy or simply as a flexible tool for analysis and simulation. There are some limitations to consider, of course. I won't dwell too deeply on them, although you will find that you cannot use this process to download cities or urban areas, for instance, complete with buildings and infrastructure and so forth. But you can download real-world terrain using the World Composer asset, which uses the Microsoft Bing Maps API, and apply the satellite photo imagery onto them. In the projects that I have built since practicing with World Composer, I have come up with some best practices which I wish to share and demonstrate. Now, since I had also produced 360-degree panorama photography as an educator and as a personal hobby before, and in producing those 360-degree orthographic projections, commonly referred to as little planets, I couldn't resist when I saw that a featured asset became available a few years ago called Curved World, which might enable me to apply a curvature effect akin to a little planet using terrains in Unity. And I could. And I shall proceed to show you how to do so in this and my next tutorial. Now, you won't necessarily need the Curved World asset for your project to do this, of course. However, you will need to purchase the World Composer asset to perform this specific task. I very much enjoy the final effect I am going for in my scenes, and I consider these settings to be optimal when considering extremely large project file sizes and ensuring that GPU handling will be within an acceptable performance load. For instance, I have located where the constraints occur and offer my suggestions to balance them. Okay. Here I've got the Unity Hub 2.2.2 open, and I'm going to create a new project. And you're going to see that I'm going to name it my project name, Olympic Mountains. And I've got a folder created for the application. Okay, this is the newest version of Unity, 2019.3.0. And I'm going to open up the Asset Store window and show you that on my downloads, these are my purchases, I'm going to import some of the assets. First, I'm going to create a folder here in my project window. I'm just going to label this one Terrains. So I'm going to import the Curved World asset. and it is known as vacuum shaders. I'm also going to go ahead and import the character controller. There's this really good one, Kinematic Character Controller. I like it. You don't need it for this purpose. You can go ahead and use the character that's in your standard assets folder as well. This one, which is the terrain to mesh asset, what this does is this converts terrains into OBJ files. And it's an extra step in order to get the curved world asset working. So I'm going to go ahead and import it into my project. And then lastly, the World Composer asset right here. I'm going to import this into my project. So you can see it puts the appropriate folders in my project window. This is the instructions that it comes with. I'll walk you through the instructions. It's really good to read to get a sense of the graphics handling. And I'm just, before I do anything else, I'm going to save my project. I'll save it in the scenes folder. So in the window menu is the World Composer selection, and I will go ahead and drag this window up full size here so you can get a sense of it. The first set of instructions, well, first of all, let me close out these highlighted categories, and I'm just going to use the categories one by one. The first step is to get a Bing Maps key, and in the instructions you can follow this link to sign in to your Microsoft sign-in. You go to this Bing Maps portal and you sign in using your Microsoft account. And I'm going to go to the Bing Maps key where you can see I've got several keys that I've done this before. I'm going to follow the instructions to create a new key. And I'm going to hit create. And what it does is I can hit show key, and I'm going to highlight the characters, and I'm going to copy it and paste it into my Bing key field right here. And when you hit the F5 key, what it does is it refreshes the map, and there you can see the map is loaded. This I'm going to change it to aerial view to turn off the labels. And what you can essentially do is to orient your map, click and drag, and you can zoom in to res with higher detail. And this is going to be a location where I shall demo. Since your Bing key is all set and good, I'm going to close out the map parameters and now concentrate on the regions window. Now I'm going to go ahead and control click all the previous locations until I've just got this blank untitled area. And when you hit the E key is where you can change the name. So I'm going to Olympic Mountains and type in the new region label. And these three windows I'm going to go over. So in the areas window, I'm going to hit that picker and you left click. And when you drag there, you can see the warning that occurs right away. And so you can read about it more in the manual. There's really no way that you can download very large map sizes with high resolution. And so what you can see is that you can fiddle with the image export settings, the resolution, the height map export settings, the height map zoom settings, and you can change the grid sizes right here. And you can see I'm going to click and drag. I'm going to get a grid size of 8 across by 8 down and show you that the warning appears when I modify some of the zoom levels and resolution and such. What you want to ideally do is optimize your settings. And I have created a folder called terrains where I want to make sure that my export path is in the terrains folder. It's a custom folder that I created. And it's going to be the export path for both the height map and the image export. You can see if you fuss with the settings, that warning will often appear. So what I would advise is starting over and clicking and dragging until the warning appears, and then perhaps backing off a little bit, turning down the resolution. So I'm going to repick a new quadrant, and I'm going to make this 10 by 10 on the current settings. Let's try 10 by 10. There we go. Height map zoom of 14. I'm going to lower my resolution. There we go. And the warning disappears. And I think this will be the setting that I will go with. So this process is called the export height map. And you can see that after I have started it, those orange squares processes through the grid. And what I will do is speed up the camera. And you can see that it has now imported. And I'm going to do the same with the export images, but first I'm going to drag down the JPEG quality to 75%. I'm going to hit start, and there you can see now that those green squares will process through the grid. And right now what this is doing is downloading the image maps, and I'll speed it up right here. So I can close out the region, the height map, and the image export. And the last step to get this all stitched is to, actually I'm fine with these settings, is to hit the create terrain. Okay. This create terrain has an image import settings, which I will start now, although this step might be redundant. The reason why I'm hitting this button before creating the terrain is because I had done so and it had eliminated a glitch. But I think the asset has improved where it does it automatically. I'll show you the assets folder of where the terrains have now been imported. You can see that there is a JPEG for each quadrant of the grid with an accompanying metadata attached to it. Here you can see the preview on these images looks quite nice. And if I scroll farther down, the terrain data is in a raw file. And I'm going to make sure that the path for the exports is indeed in the terrain folder. And I'm going to hit the Create Terrain button. And what I will do is move this window off to the side to show you that as it stitches it together there, you can see the landscape attaching itself along the grid. So I'll zoom out here. There, I believe it's completed. There we go. And you can close out of the World Composer window. And you can see how the terrains are now inside a game object. I'm going to rename it from USA to custom name. And you can see where it puts the individual terrains. There they are. So I could placement of objects using the terrain tools. I could place trees. I could do anything, any type of operation that I could on a Unity terrain. But I want to turn this terrain into OBJ files so that the curved world asset will work with these terrains. So there's going to be one extra step to do so. Now what I'm going to do is drag and drop the terrain objects, and I'm going to have to open these up, and I can't drag and drop a folder. So what I'm going to do is hold down the Shift button to highlight them all. These are all 100 terrains, and I'm going to drop them in here. Remember, the grid was 10 by 10. And this is the conversion process. This takes a while to process, but I'm just going to make sure that I can apply the transformation to OBJ uniformly across all 100 game objects. So I would hit generate, and I will speed up the camera here. And I will show you that the terrains saved in the assets folder are saved in this temporary folder right up here inside temporary. Now these are the terrain assets, and the converted OBJ files will reside in the converted folder. You can see that it comes with material with the texture. Okay, so I've applied the transformation, and the old terrain, or the original terrains folder, is still there. I will explain that the curved world asset relies on attaching a shader to each OBJ file. Or each object, and any object that has the special shader attached to it will result in the curved world little planet effect that I'm going for. And here in the shaders menu shows vacuum shaders, and I have yet to install the curved world. In the meantime, I'm going to create an empty object. I'm going to name it the converted meshes. I'm going to hold down the Shift key and select all of them here. I'm going to parent them into this folder so that it's a lot tidier. I can collapse the triangle here. And so I've got two sets of terrains essentially. And I will select the original terrains and I'll just turn them off. So it's time to import the curved world asset. And if I double click on the package, it's going to uncompress and install everything. Now you'll see it in the vacuum shaders menu is the curved world settings. And there's several different bend types or different project types. You can see the classic runner, but I like this little planet effect a lot. I click update shaders. And what it does is it sets up the shaders for my intended effect. So now here what I can do is I can now apply that special shader to each of my terrain objects. And so I'm going to choose the standard curved world shader, and I will select each one and apply that. Now, unfortunately, if I try to select all, you can see that the shader selection goes away. I cannot apply the shaders to all of them at once. I gotta go through this item by item. Here you can see that I am adjusting the curved world asset settings. In order to get it applied, you first need to attach the curved world components to your character, making sure that the main camera is where the curved world script resides. You can play around with the amount of curvature, entering decimal values in the curvature size field. I've created this horizon fall-off effect, which works wonderfully. Although here, you can see it start to glitch out, especially on the edges closer to the horizon, as it blinks in and out of view, which is unacceptable. There you can see the edges. They kind of flicker. To ensure that the camera does not render more polys than it can handle, you can, of course, lower the far clipping plane here to 6,000 meters. And it performs pretty well if your project's vantage doesn't require distant objects. Except, watch what happens now when I assume an aerial perspective. See here, the limit is quite evident. Supposing I increased the main camera's far clipping plane to 100,000 meters. What you would then encounter is a lot of lagging performance and significantly dropped frame rates. When I enter play mode, and depending on the terrain sizes, I am finding that although it beautifully renders the distant objects, the simulation is unacceptably slow. One solution I have found which works wonderfully is you can create a sky dome, set the diameter to be 5,000 meters, and then parent the sky dome to follow wherever the character's camera is. In this case, I could apply my main camera's far clipping plane to be 5,001 meters and then parent the sky dome to the main camera. Here you can see the sky dome in scene view. It's following wherever the character travels with the same amount of distance clipping, which produces the same kind of clipping as the camera's clipping plane, although in this case I would be able to add some fog and still be able to keep the sky dome visible instead of being all fogged out. So you hear window, rendering, lighting settings to open up the fog density field, and here I have in the density field set the value to be 0.0003. The value f equals the fog density times the distance. So here when I enter play mode, the effect is quite desirable. Except there is one glaring error, which I'll show if you can detect it. You see here, every time I move the forward key, can you see it? The sky dome not only follows the camera around, it quite literally follows the camera around. So in other words, the sky dome is rotating to the orientation of the character whenever I hit the forward key. Here you can see I'll hit the forward key, I'll move. You can see how the glitch happens. To stop this from happening, I found a most helpful suggestion from the following answers.unity.com site: how to freeze child game object rotation. This code, suggested by Aldonalletto, worked perfectly. You can copy and paste his example. I shall provide it below, or pause the video to type it in yourself. What you have to do is to attach a new C# script to a game object, in this case to the Sky Dome. I'll name it Don't Rotate. And double-click on it to open it up in Visual Studio. This pre-generated template, I'll just go ahead and highlight and delete it out. The class code fits inside this set of curly braces, and I'll type out quaternion. A quaternion represents the rotation. In this case, I want the Sky Dome to stop rotating wherever I rotate. I will type out the following. Okay, here I'm going to go to File and save my script. I'm going to close out of Visual Studio, and I'm going to make sure that I select the Sky Dome game object and I add a component. I'm going to search for my script. Don't rotate. And now when I hit play, you'll see here I will move forward, change my rotation angle, and the Sky Dome remains true to form, rotation free. So it looks good. It works great. Thank you for watching. I hope this was a useful tutorial for you, and I'll proceed to explore more of the curved world settings in a future tutorial. In any case, thanks for watching.